Hey, I just want to start off by apologizing for the fact that I'm not dressed very professionally today, don't have a collar on, but hey, here we go. Let's talk about the impacts that human activities have on these natural cycles that we've talked about. So basically, humans have been successful as a species because we're really good at altering our environment to suit our needs. We clear land for agriculture, we build houses and structures, we make tools. We learn how to use the different resources, the mineral resources that the planet has, but these have these unintended consequences on these natural systems that we end up disrupting accidentally. And so let's just look at some of the main ways in which this happens. Okay, so what we're going to focus on is these four different cycles that are covered in this section of the course, that being the hydrologic cycle or water cycle, the carbon cycle, nitrogen cycle, and the phosphorus cycle. So let's just go through each of these in turn and see how our behaviors impact these. Okay, so let's start off with the hydrologic cycle. So there are lots of ways, and we'll cover later on in the year. But for right now, let's just talk about the main ways that we impact the hydrologic cycle are through deforestation. So humans have, as our populations grow, we clear out land, we cut down forests, we plant croplands. But when we cut down trees, what happens is, remember, trees basically slow down the rate at which rain gets to the ground, and it takes time for water to seep into the ground and infiltrate and become groundwater. And if it's coming down too fast, especially on a tilted surface, then it just turns into runoff. And so we find is deforestation tends to lead to a certain number of consequences, those being less infiltration. So that means that our aquifers don't get recharged. So there's less groundwater available for, say, drinking purposes or recharging rivers. This also means there's going to be more runoff because if it can't go into the ground, it's going to go over the ground. And when that happens, it picks up speed and momentum and it carries particles with it. And what that does is that causes erosion, carrying soil away with it, and it also causes flooding when it reaches surface streams. The other thing is afterwards there's less vegetation there, so there's less transpiration occurring, so there's less water going up into the atmosphere. As a consequence of this, it can cause a change in weather patterns. So we find that, say, for instance, as we clear out large areas of rainforest, we end up altering the hydrologic cycling area where there's less rain to have a rainforest because there's just not as much water going to the atmosphere. And the other thing to keep in mind always with this is that the steeper the terrain is, the more pronounced these effects are going to be, especially with regards to erosion and flooding. So basically, steeper terrain just allows for a much more rapid movement of water across the surface. Now, another way that we impact the hydrologic cycle is through urbanization. When we build cities, we basically have roofs that don't let water in. That's kind of the point of a roof. We call that an impervious surface. We put in pavement, and in doing so, basically, we are clearly preventing water from infiltrating. So again, we're going to negatively impact the rate of recharge of aquifers, and we're also going to cause that water that can't go into the ground has to go over the ground as runoff. So we end up with more urban flooding as a consequence of this. And again, just like before, if there's no trees because we cleared them out and replaced them with concrete, steel, and asphalt, then there's going to be less precipitation. And what we find is large mega cities like Seoul make their own weather because of this change in the amount of moisture returning to the atmosphere. Now let's talk about the carbon cycle. We'll have a lot to say about that this year, especially at the end of the year in our last unit. But for right now, let's just say this. Okay, here's what happens. Human society for the last 150 years has been driven by the use of fossil fuels. Now remember, fossil fuels are basically carbon sinks, part of the slow carbon cycle. And so we're taking carbon that's been underground for millions of years, sometimes tens and hundreds of millions of years, and we're converting it into carbon dioxide and dumping it into the atmosphere. So we're very, very rapidly and uh, 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 bigly and largely impacting the amount of carbon dioxide in the atmosphere. Again, we'll have a lot to say about that this year. And the other thing is deforestation, because just as burning fossil fuels puts more carbon dioxide in the atmosphere, deforestation prevents carbon dioxide from being taken out of the atmosphere through photosynthesis and productivity. So these two things combined, unfortunately, have a tendency to increase the amount of CO2 in our planet that's in the atmosphere. Now, the nitrogen cycle, a lot of this have to do with agricultural practices. So basically, uh, in agriculture, we tend to spray down pesticides. We irrigate the plants. So, we put pesticides to kill pests. Okay, we put irrigation water down to provide the plants with water for photosynthesis, and then between seasons, we tend to churn the soil to reduce the amount of weeds that are competing with our crops. Well, all of these processes have a tendency to negatively impact soil bacteria. And since nitrogen fixing bacteria in the soil are basically a main step in the nitrogen cycle, we profoundly impact the nitrogen cycle in agricultural areas by these practices. Another thing is we because we do that, because our behaviors reduce the amount of nitrogen present in these croplands, our plants, that's a limiting resource. So we say, well, what do we do about that? I know, we'll make chemical fertilizers. And so we just synthetically produce nitrogen compounds, like say ammonium nitrate, and we put it in the soil. Well, guess what? The plants grow great, but a lot of that ends up being carried away through runoff, and it ends up in aquatic ecosystems, and it causes a lot of problems there by greatly increasing the amount of nitrogen in that system from what nature would have. Another thing is when we went you're looking here at a picture of corn. What's going to happen at the end of the year is the farmer's not just going to harvest the corn, the ears of corn that people want to eat and animals want to eat, but they're also going to chop down all the vegetation that's there, and then they just take that and they just get rid of it. Well, if it had gone back down, if it was just left in place, which it isn't, but if it was, then it would decompose and return the nitrogen in these leaves and in these stalks. It would get returned to the ground through the process of ammonification. But that's not happening because we remove that plant material afterwards. And then apart from agriculture, deforestation also is going to lead to increased runoff, as we said, the hydrologic cycle. But that increased runoff tends to cause, as we said before, um, it causes erosion. Well, this erosion is going to carry soil with it, and that soil has a lot of nutrients, nitrogen nutrients in it. So we're going to carry that away from that area. So these are the ways we impact the nitrogen cycle. It's very similar with the phosphorus cycle. So with the phosphorus cycle, it's very similar. Like deforestation is, when it carries away nutrients, it's not just carrying away nitrogenous nutrients, it's also carrying away phosphorus nutrients. But another thing is that we tend to use high phosphorus fertilizers and high phosphorus detergents. And this phosphorus is called phosphate, and it's very water soluble, and it gets into our aquatic ecosystems. And again, it disrupts those ecosystems by providing with excess nutrients, which causes imbalances in the biotic factors. Hey, thanks for watching. Try to keep this one short.